All right, so we're going to look and see what method worked well for which system. And you can flip through and look at the other people's options, or if you just want to make notes of what we're talking about, your page 36 has all of what we're talking about right now. But I want you to also look at your systems page on 33 through 35. The recycling. Okay, I was like, what is that? Plastics. So, we're going to look at, this one is system 1, which is, for person A, it was the one you did by graphing. For B, you did it by substitution. And for C, you did it with elimination. So, what did you guys get as a solution? Did we get our point where they cross? So my group B people, you did this as substitution. Did we figure out where these guys cross? Or even part of it? 3-1. My people that were group A, did your lines cross at about 3-1? And for my linear combination people, you should have wound up in the same way. Then we're going to think about which one of these ways was easy. And this is one, it's not too bad in any of these options. So this one, it's not hard to switch it to slope-intercept form. Yes, my dear.
Oh, I was trying to answer the question.
Oh, yeah, go ahead.
Basically, if I'm elimination theory, we might have to,
Yeah. Yeah, this one is set up gorgeously for elimination because my y's are already set up to cancel out right here. This one's not awful for substitution because we don't have too many coefficients. And it's not awful for graphing. So, like, this one isn't awful because it's got enough low coefficients. It doesn't have coefficients everywhere and all that jazz. So, I would say this one is ideal for elimination, but because of our no coefficients and our already opposite signs. Which I know this is kind of a weird setup there. So we've got opposite signs and our not really tons of coefficients. So elimination is easy on this one, but the others aren't the worst. Let's look at system number 2, which is person A's substitution, person B's elimination, and person 3's graphing. Or I'm sorry, A's substitution, B's elimination, C's graphing, because I'm paying attention to the letters. Did we get a solution on this one? I'm gonna go with person, group A probably had the best odds of a solution on this one. Okay, I'll give it to you guys. So we've got we should have wound up with an x of negative 2.5. We're going to have things with decimals. And a y of negative 4. It is doable to do this with the other methods. It is possible to use it as elimination, though that one is probably like the worst. It is possible to graph this. Totally a thing. What is the easiest way to solve this system as looking at it? Substitution. Why? Yeah. I've already got a y equals, which means I can just straight up take this dude and substitute it in. Plug it in right there. I know that y equals 4x plus 6. So in the second equation, I'm going to replace the y with 4x plus 6. We already have a y equals. If you have a y equals or an x equals, ooh, that's impossible to read on there. If you have an y equals or an x equals, head for substitution. That's going to be your easiest way to do it. It is absolutely doable using it as our graphic. That's what group C did. It's possible because we've got a slope-intercept form there. And we can solve the second one into slope-intercept form. We're going to wind up with fractions, and it's gross, but it's doable. Probably the hardest one on this one was person B's method, where it's elimination using this, because we have to solve it to not be a substitution, and then do elimination, and it's gross. Doable, but gross. All right, then let's look at system 3 up here, which was person A's elimination, person B's graphing, and person C's substitution. Do we have a solution on this one? Two, one. Which method is going to be easiest on this one? None of them are single steppers. But which one is the least awful? Or which one would be the most awful? I'd say group C probably had the worst option on this one. Doing this with substitution, because we have to solve to get to an x equals or a y equals, then substitute it in, and we're going to have fractions out the wazoo. So doing this one with substitution is probably the worst. Yes, my dear.
Looking at it, I didn't really know if I solved it real well, so I would probably have to go with elimination.
Yeah. I agree. Elimination is probably going to be our best option here. Elimination is when I'm going to take these equations and make it so that my coefficients, that was not what I intended. So my coefficients have that opposite sign but the same number. So I'm going to have to multiply these to do it and multiply the whole equation. And you can do either one of these. We could get both of our x's to be 15x, or I could get both of my y's to be 6y. Probably the y's are going to be easier. So what I would do here is I would multiply this top equation by 3 and this bottom equation by 2. We have too many coefficients here to make substitution likely. That's an I. So too many coefficients. To make substitution really easy. But our elimination or our linear combination, that'll work when we have just about anything in that standard form. Like that's going to be how it's easiest to get the standard form ones to solve. If we have one that's a y equals or one that's easily put into a y equals, we could absolutely do this one into substitution in a single step. Like that's 100% doable. So this one we could do either way. This one is ideal for substitution. This one is more ideal for linear combination or elimination. Why didn't we put graphing as the ideal solution for any of these? Why isn't graphing the preferred method for any of them? Yeah.
Obviously, because they have an equals to them and equals a number, it just more steps.
Yeah.
It's just graphing them in general.
Graphing them takes more steps, absolutely. Very, like we only had one up here that was in slope-intercept form, which is our default. Sweet, I can graph that guy. Let's kick it. Also, on something like this, would it be really easy to tell where our answer was on a graph? So, yeah, it's one of those things that just doesn't work all that well. Especially because when I did this system by graphing, I got really ucky decimals because things weren't crossing correctly because we wound up with fractions, which I just realized when I did this. So graphing is the least accurate because we're having to read based off of our human error. Graphing takes more time. Sometimes we run with gross fractions. So more often than not, when we work through this chapter, we are going to be doing it algebraically, which is what we do with the numbers and stuff, the not graphing. Graphing is an option. We do have grids and graphs whenever we need to. If you want to graph every single one of the ones we're going to do, I've got graph paper over there under the turn-in bin, the very bottom tray. Graph it to high heaven whenever you want. Just make sure you use rulers. But more often than not, we are going to solve algebraically because it gives us our more accurate answer. It lets us find our decimals where we can tell if it's negative 2.5 versus negative 2.4. Okay, so that is kind of the gist of what we're doing, and it gives us kind of that rundown on all three of these methods. We are going to continue working with these methods. We are going to together go through and do substitution and elimination and graphing tomorrow together. This was kind of a see what we remember situation versus a this is the only time we're going to do it situation. So, yeah. That's all I got for you today. You have less than 10 or about 10 minutes till the end of the period. The tests are graded in. They're in on Skyward. They were in general not bad. In general, not too shabby, y'all. There may be some people that are not super pleased with their grade. If you are not pleased with your grade on the test, the pink paper around the room, it's in about 6 places, is the retake policy. All your homework must be in. You've got to come in and do corrections on the first test so we know what to do to make it up. And then you've got to schedule a time for a retake. You can't take it in class because you don't want to fall behind in the current chapter. But that's pretty much it. For the most part, I think they were all right. If you want to see them, I have them. You're welcome to come see them. But other than that, that's all I got for you today.